All right, these are the answers to page 409. The first few want us to verify that this function is a solution to this differential equation. So this 4 means the fourth root. So what we're going to do is we're going to take the fourth derivative of this function. So the first derivative would be 3 times derivative of cosine. That would be a negative sine. The second derivative will be negative 3 times derivative of sine, so that's negative 3 cosine. The third derivative here would be negative 3 times derivative of cosine, so that's going to be a positive 3 sine. And then the fourth derivative of this will be 3 times derivative of sine, so that's just 3 cosine x. Okay? So we have our fourth derivative of this. If we put that right there, we get 3 cosine x minus 16 times the original function, which was 3 cosine x. And I end up with 3 minus 48, that's a negative 45 cosine x, not the 0 we were looking for, so we would say no, it's not a solution. Okay. Number 19, they want to know if this is a solution to this equation here. So we're going to take the, we need y, which is already here, and we need y prime. So y prime is easy enough, that's going to be 2x. Look and see, is there anything else you need? You don't need a second or third derivative or anything like that, so we'll just use these here. So we now have x times the first derivative, which is 2x, minus 2 times y, which is x squared. That's 2x squared minus 2x squared, which is 0. That does not equal the x cubed e to the x that we were looking for. So this is also not a solution. Okay. But now for 20, we're looking at this one and asking, does this actually work here? So if I take the derivative, this is a product rule. So it's derivative of x squared, leave e to the x alone, plus now leave x squared alone, times derivative of e to the x, which is still e to the x. Okay, so now I have x times y prime, so x times 2x e to the x, plus x squared e to the x, okay, minus 2 times y, which is x squared e to the x, equals x cubed e to the x. So if I distribute, we get 2x squared e to the x plus x cubed e to the x minus 2x squared e to the x equals x cubed e to the x. These cancel, and we end up with that equal to that. So yes, this is a solution to that differential equation. For 31, we're saying, does this satisfy this? And then once we verify that, let's find the c value that makes this true. So 2 steps here. First, let's take the derivative of this. Derivative is going to be c times derivative of e, which is just a repeat, times the derivative of the exponent, which is negative 2. So we end up with negative 2c e to the negative 2x. That's our derivative. Okay. So now the function here, it says y prime, which we just found, negative 2c e to the negative 2x, plus 2 times y, which is c e to the negative 2x, equals 0. Sure enough, those cancel. So yes, this is a solution. Okay. Now for the second part, we're putting 3 in for y and 0 in for x. So we're going to get 3 equals c times e to the 0. So c equals 3. So that specific solution then is y equal 3 times e to the negative 2x. That'd be our answer there. For this next part, they gave you 4 slope fields and asked which to match them to this right here. So when we're creating a slope field from an equation, what we want to do is kind of look, when would the slopes be 0? So for cosine 2x, we're going to get 0 slopes at pi over 2. Actually, I'm sorry, at pi over 4, and at so again, if you think about the cosine graph, it equals 0 at pi over 2, which means we'd go pi over 4 times 2 to get there. Also at 3 pi over 2, so this would be 3 pi over 4. Okay, and then we could keep doing that if we wanted. And now I'm going to look at my options and say, okay, when I'm at pi over 4, when I'm at about 0.75, which one of these gives me 0 there, which one gives me 0 around here, and that looked like option B. Okay. For 54, I'm going to have 0 slopes, or when I mean 0 slopes, I mean slope that's horizontal. I'm going to have a 0 slope at 0, at pi, at 2 pi, and so on. Okay, so I'm looking at the graph saying, where do I have a slope that's 0 at pi, and at 2 pi, and at 3 pi, and if I look at that, it sure does look like that's happening for option C. C has 0 slopes on the 0 line, and so on and so forth. 55, I'm not going to be able to get e to the negative 2x equals 0, but I do notice that e to any power is always positive, so our slopes for this one should always be positive. So then I look at my options, and of the ones that I'm looking at, there's only one that has positive slopes for everything, and that's D. And obviously A is the one that's left over here, but again, I can kind of look at this and say, you know, when x is less than 0, I should be looking at negative slopes. When x is greater than 0, I should be looking at positive slopes. And sure enough, on A, that's exactly what we're looking at right there. All right, 59 wants us to sketch a slope field for this here. So if I'm looking at 0, 0, if I put 0, 0 in, I'm going to get a slope of 0 for that. We're just going to go ahead and kind of do from, say, 2 to negative 2. So at 1, 0, if I put 1, 0 in, I should get negative 2. If I put 2, 0 in, I should get negative 4. If I put negative 1, 0, I should get positive 2. Negative 2, 0 should be positive 4. Okay. If I go up to 0, 1, I should have a slope of 1. 1, 1 should be a slope of negative 1. 1, 2 should be a slope of negative 3. Negative 1, 1 should be a slope of 3. This would be a slope of 5. If I go 0, 2, that'll be a slope of 2. 1, 2 should be a slope of 0. And then 2, 2 should be a slope of negative 2. Negative 1, 2 should be a slope of 4. And this should be a slope of 6. Right? Then down here, 0, negative 1 would be a slope of negative 1. 1, negative 1 would be a slope of negative 3. 1, 2, negative 1 would be a slope of negative 5. Negative 1 would be a slope of positive 1. Negative 2, negative 1 would be a slope of positive 3. And then lastly down here, 0, negative 2 would be a slope of negative 2. 1, negative 2 would be a slope of negative 4. This would be a slope of negative 6. And at negative 1, negative 2 would be a slope of 0 again. And then this would be positive. So what you want to do is make sure you have these zeros correct. The AP will give you a point usually for having those zeros correct. And make sure you have positives on this side and you have negatives on this side. If you have that correct, you'll usually get a point for that as well. Then they wanted us to trace what's going on at 1, 1. So if you go to 1, 1 and you kind of trace it through, you just kind of follow your marks. It looks kind of almost parabolic. Okay, so it kind of looks like this. And it says, well, what happens, you know, if x is going off to infinity, what's going on? Well, this is heading, the function, if you will, is heading towards negative infinity. It's heading down as x gets bigger and bigger. And as x goes to negative infinity, the function also is heading down that way too. Right? If we were to flatline, if we were head like off to an asymptote, then that would be our limit there, but that's what we see on this one here.